King's Learning Center. I'm Mr. B. During this lesson, I will explain how to name Arrhenius acids and bases. Let's begin the lesson with Arrhenius acids. The general formula for an Arrhenius acid is HA. H represents a hydrogen ion and A represents an anion, where an anion may be the ion of a nonmetallic element or a polyatomic ion. Arrhenius acids may be binary molecular compounds or binary acids or ternary molecular compounds or ternary acids. When naming binary acids, use the prefix hydro. Then use the root of the nonmetallic element. In this case, the nonmetallic element is, of course, chlorine or the chloride anion. The suffix will be IC, and the last word in the name will be acid. In this example, the acid contains the chloride ion, so the name of this binary acid is hydrochloric acid, HCl. The group 17 elements will all form binary acids. These acids are listed here in order of increasing strength, where the weakest acid is HF, hydrofluoric acid. Then we have HCl, hydrochloric acid, HBr, hydrobromic acid, and HI, hydroiodic acid. Ternary acids will contain one or more hydrogen ions and a polyatomic ion. When naming ternary acids, the polyatomic ion must be considered. If the name of the polyatomic ion ends with ATE, then use the IC suffix when naming the acid. The last word in the name, of course, will be acid. In this example, H2SO4 contains the sulfate polyatomic ion, so the name of this acid will be sulfuric acid. And H2SO3 contains the sulfite polyatomic ion. Therefore, the name of this acid will be sulfurous acid. In general, the more oxygens a polyatomic ion contains, the stronger the acid will be. So H2SO4 contains the sulfate polyatomic ion, and H2SO3 contains the sulfite polyatomic ion. H2SO4 will be the stronger acid. The same logic applies to HNO3, which contains the nitrate polyatomic ion, and HNO2, which contains the nitrite polyatomic ion. In this example, the nitric acid will be the stronger acid, since this polyatomic ion contains more oxygen atoms. Most of the acids that you will need to know, however, for the Regents exam are located on Table K of your Regents chemistry reference tables. And by the way, these acids are listed in order of decreasing strength. So the weakest acid on this table is ethanoic acid. HCl is a binary acid. The other acids are all called ternary acids, and acetic acid is called an organic acid. Now for naming Arrhenius bases. The general formula for an Arrhenius base is MOH, where M represents a metallic ion and OH represents the polyatomic ion, hydroxide. When naming Arrhenius bases, use the name of the metallic element directly. The last word in the name will be hydroxide. This base contains the ion of sodium and the hydroxide polyatomic ion. So this base is called sodium hydroxide. Other examples of Arrhenius bases include KOH, potassium hydroxide, CaOH2, calcium hydroxide, and NH4OH, This base is called ammonium hydroxide. Ammonium hydroxide does not contain a metallic ion, but it still fits the definition of an Arrhenius base since it will dissociate to produce hydroxide ions. Most of the bases that you will need to know for the chemistry readings exam, of course, are located on table L of your chemistry reference tables. With the exception of aqueous ammonia, all of the bases on table L are metal hydroxide compounds, which fits the MOH general formula. These compounds will contain both ionic and covalent bonding, by the way. Okay, let's try to apply what you learned to a few practice questions. Name the following acids. HClO3. Well, HClO3 contains the chlorate polyatomic ion. Therefore, HClO3 is called chloric acid. HNO2 contains the nitrite polyatomic ion. This acid is called nitrous acid. Now let's name the following bases. Let's see if we remember what I taught in the lesson. CaOH2 contains the calcium ion. Can you name this base? Of course you can. This base is called calcium hydroxide. And LiOH contains the lithium ion. The name of this base will be lithium hydroxide. Okay, this concludes my explanation of how to name Arrhenius acids and bases. Hopefully this video has been helpful. And remember, should you need more assistance, feel free to visit my Facebook page at facebook.com/WPHS Chemistry. Thanks for watching and good luck on your upcoming examination. I know you'll do well. Take care.